Hi, welcome to development log 15 of MegaSplat. This is based on the 1.04 version, which I am currently working on. So a couple new features today that we're going to talk about. Been mostly focused on bug fixes, but I keep putting some interesting stuff in anyway because it's fun. So I added this to the 1.03 version, but since I haven't shown that off in one of my development logs, I figured I would. And that feature is rain on the puddles. And so basically that's with rain on, and then when you turn it off, it'll sort of dampen down. And the way this works is that first you enable it in the compiler options here with this Raindrops. And this works in either puddle or puddle flow mode. And what it does is there's a small texture here, which I've included in the package called Water Ripple. And basically it has a special data encoded in it, which is the normal direction and then the distance from the center of the ripple. So if you wanted to make your own, you could, but there's not a whole lot of reason to do that. And then basically there's this rain intensity flag here, and you can move that up or down and get more raindrops. And then there's a separate UV scale because, for instance, if I have my puddle scale, let's say I really crank that up to 200, you get really little tiny raindrops, right? That might be too small. If I set it to 1, I get really, really tiny raindrops, right? They're really small. And so that might not be noticeable from your view angle. So basically there's an extra scaler here so that you can control the size of those raindrops. When you're in flow mode, it actually flows them as well. So you get a little extra distortion there from the flow mapping. So that's raindrops, pretty simple. All this puddle stuff is based off Sebastian Lagarde's work, who did really great research into puddles and things like that and porosity, and he's actually at Unity now. And pretty much everybody uses his stuff because it's awesome and it's very simple and it works very well. So on to the next thing. The next thing I'm going to talk about is procedural texturing. So I had a user who came to me, and I'm just going to make a new scene here. And basically, he had a voxel engine, and he was looking for a triplanar texturing shader. Now, he saw the description of MegaSplat and really liked what he saw, and then basically figured, oh, great, this has triplanar texturing, so I'll just use this. And so he grabbed it, and he realized that there's not really a common way to determine the difference because people tend to mix up these terms. But what MegaSplat supported originally was triplanar UVs, which is the ability to generate UVs from a triplanar projection. It did not actually do triplanar, I guess, projective texturing, which is where you actually choose textures based on the side or the top. It expected you to paint everything. And if you're painting, it has, it looks great that way. But if you cannot paint your terrains for some reason, then that maybe doesn't work so well for you. And so he was in a case where he had a voxel engine that he didn't want to modify, didn't know necessarily how to modify, but he was working for his game, and we said, can we just get top, front, and side textures on this? So I went back and forth a little bit onto what he was really looking for, and basically what it came down to is that he wanted that automatic texturing, and he also wanted texture clusters and sort of the features that MegaSplat provides. So I'm just going to grab a material setup for this, which is here we go. I'm going to throw this on here. And this is just standard MegaSplat shader, but in this case what we're actually doing is we are fully procedurally generating the paint job. So I haven't painted this mesh at all. I've just slapped on this shader, and now everything is being textured according to a rule set, and it's being done on the GPU basically on the fly. So if we change geometry or add geometry, it all just gets textured based on these rules. So let's show off how that works. The first thing I'm going to do actually is switch to a one layer shader. And this up, let it recompile. So what we have now, and the interface may change on this because I've still got a lot more work to do on it, is that on this bottom layer here we can say that it's either painted, which is the default, and that's how it's always been in MegaSplat, or projected three-way, which is this new option. And then you can choose that you want the space in either world or local space. So once you do this, you get a new set of options here, which is basically the texture projection editor. And so because we're all operating on the GPU, I don't have access to the CPU side stuff of like texture clusters and stuff. So what you actually do is you set up little texture clusters here, and you get 3 textures per projection. So we have 3 top textures, 3 side textures, and 3 bottom textures. And basically, as we change these, you'll see it just changes, right as we change. So there's just awesome instant feedback. You're not going to get, you don't have to like sit and paint and stuff. So it's really pretty nice because I'll just do that one. You can just get this feedback, instantly as you change stuff. And then you have the same thing for the side texture. So basically, what I have is I have some moss, grass, whatever, for the top projection, which is going to be flat areas. And then I have for the sides, I have this rocky cliff. And then for the undersides of things, I have this these dirts and stuff that'll get all mixed up. So this model doesn't really have an underside. So one thing that's nice is I provide this side threshold. And so what this is really where do we consider the side to be? So by default this is set somewhere in the middle, which means basically if the angle of the normal is faced sideways as opposed to up or down, then great, we will use the side textures or we'll use the top or bottom accordingly. Well, I can adjust that. I can pull this in really tight. And as I do that, you'll see all the texturing updating and say, no, the side is only between these like very specific angles, or I can make it much wider where the side even just covers the top. So unlike a traditional shader, you really have control over this projection, over what angles you want to consider your top, front, and side. So this is pretty cool. There's one other thing I want to talk about with it, which is a larger thing I want to produce a video on, which is texture cluster scale. So I did a bunch of work on Unity trains for the Gaia converter that I'm working on, and noticed that the texture cluster scale had to be set incredibly small for Unity trains. And I also noticed that what a lot of people do with trains is not what I do. I tend to make them very low res in terms of their control texture. People are making very high control textures where it's like 2048 on a basic terrain, so they could paint really small details. I tend not to do that. I think MegaSplat looks better with wider control maps, like lower res control maps. It's one of those rare cases in graphics where things being lower res helps. But what it did make me realize is that not only were these values tuned wrong, and I needed to fix that, and there wasn't actually on the train converter a way to control the cluster size, but that people really probably weren't understanding what this control does, and were asking me for various things about tiling or complaining about things looking a certain way, mainly because of the cluster noise and not realizing what was going on. So I need to produce some videos explaining that, but what's nice about this technique is that as I adjust this cluster size here, you can see everything happening in real time. And basically what it is that when you get to really low frequency cluster noise, you get patches of stuff. So we end up with, instead of having, so see this darker grass here, right here, and let me just tighten up the blend so we can see this a little bit better. So if I tighten the blend way up, you can see the patterning that happens because it's chosen these very discrete sections. But you can see that it's chosen like this sort of large patch here to be one texture and this other patch here to be another texture. And that's kind of what we want from cluster noise. We want it to actually show you the full texture before going on to the next area. If you have this noise set too high, like if I set it to 1, what you get is these tiny little patches. And so if you imagine that we had both textures in Photoshop on top of each other, if our control texture is really high res, then what we can actually do is transition between these textures 3 or 4 times before you even draw one of them. And so that's not going to look very good. It's going to end up synthesizing some weird combination of the textures. So what you want to do is I've basically normalized everything so that the idea is that under most scales, a value of around 0.05 will produce this sort of areas of patchiness that you like. And then you can adjust that up or down to get something more the size that you want. And you can see as we go lower, we get big wide patches of things. And then things are going to start to look like they're tiling. But done right, with a right nice sort of scale, it produces the result we want. And for this, I think we wanted it around 0.9. That's kind of where I like it. And then I'm going to loosen that blend a little bit. That's cluster noise scale. I'm going to do some more video on that to help explain it better. So like most techniques with MegaSplat, because the raw technique we're using is so different, the code ends up looking different. The ramifications of that code, both from a performance standpoint or from a visual standpoint, can look very different. So one of the things is that MegaSplat is doing all this work in the Vertex Shader. So there's no difference to the pixel shader cost of running this with procedural textures versus the regular textures. All the difference is done in the Vertex Shader, and obviously there's far less vertices than there are pixels on the screen. So that makes it faster than most of these triplanar texturing techniques that are available, which is great. We always love faster. And we burn a few extra cycles to do things like choosing which texture and get quality improvements and things that we want. But overall, it should be fairly fast because we tend to draw more pixels than we do vertices. Another thing about this is that since we have a 2-layer shader available to us, we'll switch to 2-layer mode. And what's happened here is that our second layer is set to painted. So by default, the vertices are basically slammed to some value that's making this second layer show up. So we could go and we could paint, and we could actually paint over our projected texturing there. But we can also set this to project the second layer's texturing. Now, why would you want two versions of this? Well, because now what we get is we get another 3 top, 3 side, and 3 bottom layers, again with our side threshold that we can adjust to control where those textures end up and when they transition, and then our cluster scale, which again can be very different than the other one, which can give us a nice rich look. And then finally what we have is we have a noise function that controls when it's going to blend into the top layer and when it's going to be the bottom layer. And so this works very similar to the noise function in the cluster scale. So we set it to sound resolution. If we set this really high, we're going to see it sort of quickly move back and forth between the top and the bottom layers in a really obnoxious, noisy way. But if we set it down to something like 0.05 or 0.04, we start getting these like patches where now what we see is we have a big patch of the bottom layer and then we have some of the top layer coming in. We can also set the amplitude here, and what this does is control how strong that blend is. So as we raise it up, it's going to be more either it's the bottom or the top, whereas if you lower it down, you're going to get the sort of the blend between the two, where little rocks start popping out, but the whole surface doesn't come in. And you can even go negative, which will like invert the areas for you. So that's pretty cool. But the really cool thing is, and we'll just leave that at like maybe 1.5 is a good amplitude for this. So now what we can do is go down to here, which I have not labeled this slider yet, but basically what this is the min and the max of the noise. So if I lower this all the way down, you'll see that we're just getting the bottom layer. And as I raise this up, you can see that those little stones pop through from the top layer first, just like if we were painting lightly. And then the color starts coming in. And again, it's following that noise, so it's only doing it where the noise is. And then when we bring it all the way up now, we're actually going to get a full blend between the two layers. And also, if we move the bottom of this, we bring this bottom up, you'll see that now what's happening is we're blending to where the bottom layer is blending out, and eventually we get just what the top texturing is. So one thing that's really nice when you're working on this is you can flip kind of back and forth between your two texturings like this, right, of your two layers. And you can basically look at this and go, you know what, I don't like this. I want to tweak, you know, this to be a little more like that. Or maybe I want to come in here and say like, oops, side one here, change one of those textures, or maybe I don't like this texture, right? And I can come in here until I find, you know, what I'm looking for. And again, it all updates in real time, which is really fun. And then I can kind of come in here and tweak this layer, and then I can sort of set this blend to blend these two however much I want, and create a very rich procedural texturing that only takes a few minutes to set up, but looks quite good. And again, this will work with triplanar or regular UVs. It doesn't really care. But it does really create a nice first pass texturing. So when I was doing this, I was like, man, this is actually really kind of cool. But there's a couple problems. One is that to do this on a Unity train would be rather expensive because I would have to compute the stuff that I'm doing per vertex actually would have to be per pixel on a Unity train. So that kind of sucks. So the other thing I thought about is like, hey, this is really great. I can get this quick texturing, but I could have painted this, and that would be cheaper because I wouldn't have to do any of those calculations, right? I could just render the thing like normal, and I would save all those vertex calculations. So what I'm working on now, it doesn't work yet, but I can select these, and it will work eventually. I can go to the vertex painter here, and I can go to my utilities panel, and I can go to the procedural texturer. And now I can just hit bake. And the ID here, which again doesn't work yet, but it will soon, is that it's going to bake all the data that the procedural texturing created for us right onto the vertices. So now my terrain is all set up. It's got everything baked into the vertices. And now I can switch this. I can basically go back to my shader. I can turn off the procedural stuff and get rid of it. And it's all still there. And then I can paint over it and put in the pathway that I want or whatever. So, so this seems like a really exciting way forward because it really takes advantage of the power of MegaSplat, allows you to quickly texture terrains, and then once I get it finished, allow you to bake that down into the terrain. And if you are a user who has a voxel engine and you don't have a way to modify that engine to put this data on the vertices, you could use this for your full texturing in your game. And to that end, I also added this little option here called preprocess mesh. And what this does is that it will process the mesh in the geometry shader. So right now, when you set up a mesh for MegaSplat, you have to convert it into a MegaSplat format. What this does is bake some data onto it that it needs. It's really annoying. I wish I could get rid of that step, but I can't. But I can actually do that work in the geometry shader. I resisted doing this for a while because anytime you use the geometry shader, the whole thing goes a lot slower than if you didn't. So I pretty much never want to write shaders that use the geometry shader unless I can help it. But if you really have no way to convert your mesh, then basically clicking that option will pay that cost and do that work right inside the shader itself. And that can actually be really nice because maybe you're just messing around and you don't want to, put things through the converter yet, or maybe you're early in production, so you're okay with things being slower, and then you do this the conversion as an optimization step later on. So that's pretty cool. I haven't showed this yet, but if you have curved world installed, you can now click this shader and it will become a curved world shader. If you don't have it installed, it just won't do anything. And besides that, it's basically a lot of bug fixes and things like that. But yeah, so this is a pretty exciting technique. I will probably add support to do this on the terrain, Unity terrains, even though the technique I think is too slow to be really usable, but for getting a quick procedural texturing and baking it down, super useful. and really a nice way to visualize it. And then I'm also interested in people playing with this rule set and figuring out what else they would need. For instance, I could do things that allow you to filter the noise based on height or things like that, and so you could get a fully procedural textured terrain like you would in a world machine or something like that. Maybe not quite with the full feature set those programs have, but something close. And it would be right in MegaSplat and very, very fast. So that's pretty cool. And yeah, if you have any thoughts, things you'd like to see, or ideas, let me know. I'm always on the forums, and hope you've enjoyed this video. Thank you.